Good day everyone. Welcome to our lecture, our week 1 lecture sa Principles of Chemistry. So we will discuss here using our reference Chemistry Atoms First, second edition. We will be covering chapters 2, 3, and 4. Pero dun sa chapters 3 and 4, mga selected lessons lang muna, no? To equip you on the whole course and also sa mga succeeding lessons natin. So for the outline, here's the chapter outline. We will be covering chapters, sub-chapters 2.1, 2.2, 2.3, 2.4, and for the chapter 3, 3.6, and for chapter 4, yung 4.3, no? So basically, in chapter 2, we'll be covering yung basics about atoms, molecules, and ions. And then in chapter 3, we will have an overview of the arrangement of the elements in the periodic table. And in chapter 4.3, we will be taking a look and having some exercises on chemical naming or chemical nomenclature. Okay? So before we go into the details ng ating buong lesson, let us connect to the topic to real applications, no? So this figure shows that molecules in a person's exhaled breath can provide useful information about his or her health, disease, or environmental exposure. So this is possible because molecules have identities, and a molecule's identity depends on what atom it contains, no? So how many of each atoms are present and how those atoms are connected to each other. So even before we discuss complicated instruments and so on, we first need to understand that atoms, molecules, ions, and formulas have basic concepts muna na dapat nating maintindihan for those things, okay? So our learning objectives for 2.1, section 2.1. So dalawa siya, no? First is we should be able to state the postulates of Dalton's atomic theory. Second, we should use those postulates to explain two important chemical laws. So yung una is the law of definite proportions and the law of multiple proportions. So in simple terms, we are asking what did Dalton say about atoms and how did those ideas explain the fixed compositions of compounds. Sa gitna, okay. So the idea of atoms is very old, no? In the 5th century BC, the Greek philosophers Leucippus and Democritus proposed that matter was made of tiny particles. They used the word atomos, meaning indivisible. Later, Aristotle and other scientists proposed a different view, saying that matter was made from combinations of 4 elements: earth, air, fire, and water. So this idea dominated for a long time, and the modern scientific concept came much later, no, in 1807 when John Dalton proposed his atomic theory, or an atomic theory based on experimental observations and measured masses. So Dalton's atomic theory can be summarized in 5 postulates. So first, matter is composed of extremely small particles called atoms. So second, an element consists of only one type of atom and those atoms have a characteristic mass. So yung tandaan nyo. So third, atoms of one element differ from atoms of other elements. So number 4, compounds are formed when atoms of 2 or more elements combined in small whole number ratios. Okay? So, yung last is, atoms are neither created nor destroyed during a chemical change. Instead, they are rearranged, no? So this last postulate is especially important because it connects atomic theory with conservation of matter. So these figures, no, itong figure na to, it helps us connect the macroscopic world to the atomic world, no? So a pre-1982 copper penny contains around 3 times to the 10 3 times 10 to the 22 copper atoms. So that's a lot of copper atoms, no? Yung magnitude niya 10 raised to 22, no? So that is an enormous number of atoms in a very small object, no? So the important idea is that each copper atom has the same chemical properties as every other copper atom. Okay? So this supports Dalton's idea that an element is made of one type of atom. Okay. So, dito naman, here we see a copper 2 oxide. So, it is a compound made from copper atoms and oxygen atoms naman. So, the model shows copper and oxygen combined in a 1-to-1 ratio. So, this illustrates another Dalton postulate. So, ito yung compounds contain one atom of different elements in a whole number ratio, no? Just like this, yung copper to oxide, the ratio is 1 copper atom for every 1 oxygen atom. Okay? So, ito namang figure na to, no, shows a chemical change. So, copper and oxygen start as separate substances, okay? So, unang bottle, makikita nyo. So, after the reaction, ng dalawang yun, oxygen and copper, their atoms are rearranged into a new compound containing copper and oxygen. So, the atoms themselves are not destroyed, hindi siya nawala or hindi siya nasira. But they are reorganized or rearranged, no? So, this is the atomic level explanation of a chemical reaction. So, in chemistry, reactions usually do not create or destroy atoms. They change how atoms are grouped and bonded. So, which leads us to Dalton's atomic theory, no, gives a microscopic explanation of for a macroscopic observation or macroscopic property ng isang bagay. So, macroscopic means we observe it at the scale of the laboratory, like masses, solids, gases, and liquids. Well, yung microscopic means we explain it using atoms, okay? So, if atoms are neither created nor destroyed during a chemical change, then the total amount of matter should remain constant, okay? So, ulitin natin yun, ha? So, if atoms are neither created nor destroyed during a chemical change, then the total amount of matter should remain constant. So, this is the law of conservation of matter. So, in a properly closed system, the total mass before a reaction is equals to the total mass after the reaction. Okay? So, let us test Dalton's idea using this particle drawing. Okay? So, on the left, the starting material shows 2 green atoms. No, makikita niyo dito. So, meron tayong 2 green atoms on the left, bonded together. Okay? And 2 blue atoms together as well, no? Bonded together as well. So, on the right side naman, the two products, or the product shows only one blue-green unit. So, yun siya, nakaband together, no? So, count the atoms carefully. So, we started with 1, 1, 2 green atoms. Okay? So, 2 green atoms and ito, ilan to? 1, 2 blue atoms. But the product shows only ilan yung blue, 1, ilan yung green, 1 lang. No? That means atoms seem to have disappeared. No? So this violates Dalton's postulate that atoms are neither created nor destroyed during a chemical change. No? So ito ay hindi siya nag-agree, no, doon sa, or di siya nagpa-follow doon sa postulate ni Dalton na yun, no? So, let's compare naman this second figure or the second drawing under example 2.1 pa din. So, the starting materials contain, okay, bilangin natin, 1, 2, 3, 4 green atoms, okay? And ilan yung blue atoms natin? 1, tapos 2. Okay? 2 blue atoms in total. 4 green, 2 blue. The products also contain, check natin yung sa products. So, we have here 1 atom, blue atom, 2 blue atoms. Tapos ilan yung green? 1, 2, 3, 4. So, the products also contain the same number of green atoms and blue atoms in total, okay? So, therefore, the atoms are rearranged into new groupings, no? Makikita nyo, no? Different groupings lang sila compared to before, no? Pero, no atoms appear or disappear. So, this does not violate, no, the postulate ni Dalton. This is what a chemical reaction should look like at a particle level, no? Conservation of atoms with rearrangement into new substances, okay? Okay. So, the law of definite proportions naman, also called law of constant composition, states that all samples of a pure compound contain the same elements in the same proportion by mass. So, for example, pure water is always made of hydrogen and oxygen in the same mass ratio. So, on the other hand, pure carbon dioxide is always made of carbon and oxygen in the same mass ratio. So, Joseph Proust's experiments supported this idea. Okay? So, Dalton's theory explains it by saying that compounds contain atoms in fixed ratios. So, nag-agree naman silang dalawa doon. Okay. So, this table shows 3 samples of isooctane. Okay? So, each sample has a different mass of carbon and hydrogen, but the mass ratio remains the same. Mapapansin nyo, no? Iba yung sa sample A, B, C. Okay. Sample A, B, C natin, iba-iba yung kanilang ratio ng carbon tsaka hydrogen, no? Magkakaiba sila ng ratio sa isa't isa. Pero, yun nga, for example, no? Tingnan natin yung sample A. 14.82 grams of carbon divided by 2.78 grams of hydrogen gives ilan kaya? 5.33. No? So, lumalabas, meron siyang 5.33 grams of carbon per 1 gram of hydrogen. Kung titignan naman natin dito sa sample B, meron tayong this should be 22. This should be 22. Okay. So let's change this. This should be 22.33 grams of carbon over 4.19 grams of hydrogen. So pag dinivide niyo siya ulit, it will translate into 5.33 grams of carbon per 1 gram of hydrogen, no? So, ganun din yung sa sample C, no? Pag tinry nyo, same pa din yung kanilang mass ratio, no? So this is an example of law of definite proportions, okay? So the law of multiple proportions naman, no, applies when when the same two elements form more than one compound, okay? So it states that a fixed mass of one element combines with different masses of the second element in ratios of small whole numbers, no? So ulitin natin yun, no? Yung law of multiple proportions states that a fixed mass of one element combines with different masses of the second element in ratios of small whole number, no? So in this example, copper and chlorine naman form two compounds, no? Isang green solid, wait lang. Isang green solid tsaka brown solid, okay? So one green compound contains 0.558 grams of chlorine for every 1 gram of copper, while on the other hand, yung brown compound naman contains 1.116 grams of chlorine to 1 gram of copper. So if we divide 0.116, so maka-cancel na yung 1 gram ka. Hindi naman cancel. Cancel na natin yung 1 gram copper. Yung ratio nito, makikita natin na 1.116 divided by 0.558 is equal to 2/1, no? Kung lalabas, or 2. So this means that yung the brown compound has twice as much chlorine, no? So lagay natin the brown compound has 2 times much chlorine per copper compared to the green compound. Okay? Okay. So ito siya. So these figures gives the particle explanation for the law of multiple proportions. Okay? So in one compound, there is 1 copper for every 1 chlorine atom. Okay? So ito yun. No? Yung figure A. So in the other compound, there is 1 copper for every 2 chlorine atoms. No? So ito yung sa letter B. So the elements are the same, no? Magkaparas naman na chlorine at copper, but the ratios of atoms is different. Since atoms combine in whole numbers, the mass ratios also form small whole number relationship, no? As mentioned kanina. Okay. We now move on from Dalton's atomic theory, no, to the evolution of atomic theory, no, kung paano siya nagbago, no. By the end of this section, we should be able to outline the major milestones in modern atomic theory, interpret the experiments of Thomson, Millikan, tsaka si Rutherford. So we should be able also to describe the 3 subatomic particles, ano yun, electrons, protons, tsaka neutrons, and define, no, ano yung isotopes. So the key question here is now, if matter is made of atoms, what are atoms made of, no? So good. So Dalton treated atoms as the smallest unit involved in chemical change. Okay? So but scientists later asked deeper questions. Ano yung mga questions na yun, no? So are atoms truly indivisible? So is there something smaller inside the atom? So the answer turned out to be yes, no? So atoms combine subatomic particles. Okay? So in this session, we will look at how scientists discovered the electron, the nucleus, the proton, the neutrons, and some isotopes. Okay? Okay, let's start with this one. So, J.J. Thomson studied cathode ray tubes or CRTs. Natin dyan, CRTs. CRT. So, a cathode ray tube is a sealed glass tube with almost all the air removed, no, dun sa tube na yun. So, inside it are two metal electrodes. So, when high voltage is applied, a visible beam called a cathode ray appears doon sa tube. So, Thomson observed that the beam was deflected toward a positive charge and away from a negative charge. So, since opposite charges attract, this shows that the cathode ray particles were negatively charged. Bakit kaya? Since na-attract siya dun sa positive charge, no? Nade-deflect siya dun. So, yun. He also calculated yung charge to mass ratio. Okay? Nung cathode ray particles. So, ano ang nangyari dun sa experiment niya na yun? Okay? So, Thomson found out that cathode ray particles were much lighter than atoms. They were negatively charged, and they were the same regardless of the metal used in the experiment. So, this means they were not specific to one type of atom. So, they were a basic part of all atoms. Okay? So, hindi siya specific sa isang atom, no? Hindi siya nagbabago ng property. Today, no? Ngayon, we call this particle the electron. So, yun yung discovery ng electron, no? So, the electron is a negatively charged subatomic particle with a mass more than 1,000 times smaller than that of the atom. Okay? Of an atom. So, this figure summarizes yung experiment ni Thomson sa CRT. So, the yellow beam travels. So, mapansin nyo dito, no? Try natin siyang i-highlight ng red. Kung makikita. So, yan. So, yung yellow beam travels from the cathode toward the anode and then to the fluorescent screen. Okay? Ito yun. Ganun siya. Okay? So, by applying electric and magnetic fields, so saan galing yun? So, ito yun. May magnets dito. May magnet ka dito, north and south pole, tapos may electric field ka din, no? Yun yung plates na nakikita niya dito, yung kulay. Ito, yung green na yan. So, may electric field, tsaka may magnetic field. And, nakikita niyo na deflect yung dito, no? Nag-deflect siya sa positive side. No? So, yun. Ino-observe kung paano nagde-deflect yung beam, no? So, baka mamaya hanap niyo yung positive side. Ito siya. Positive plate, negative plate. Okay? Kasi nga din yung electrical charge. So, Thomson determined that the particles in the beam had a negative charge and a very small mass. No? This was a strong evidence that atoms are divisible and contain smaller particles. Okay? So, yun yung experiment niya. And that's how the electron was discovered. Pero, yan. So, after naman nung experiment ni Thomson, after niya ma-identify yung electron tsaka yung charge to mass ratio. So, si Robert Millikan measured the charge, okay, of the electron using the oil drop experiment. So, Millikan created tiny oil droplets that carried electrical charge. Okay, may electrical charge na yung oil droplets. So, these droplets naturally fell because of gravity, but an electric field could slow them down pala. So, electric field could slow them down or even push them upward. So by carefully balancing gravity and electric force, so Mini can determine the charge on individual oil drops. So this figure represents yung oil drop experiment. Okay? So the important observation is that the measured charges of oil drops were not random values, no? Kung makikita nyo dun sa table, ito si oil drop A, B, C, D, E. Makikita nyo yung kanilang charge, no? In units of column. They always appeared as multiples of a smallest charge. Kung makikita nyo siya, no? So, that smallest charge was interpreted as the charge of one electron. Okay? In other words, a droplet could have one extra electron, two extra electrons, and so on, no? Pero yung multiples niya is makikita nyo the same siya, no? So, from 1.6, kuwari 1.6, tapos kuwari 2, 3.2, so times 2 ng 1.6, and times 3 ng 1.6 is 4.8, may multiple siya. So, doon niya nakita yung doon siya nagkaroon ng idea kung ano yung charge. So, dito sa computation, no? So, Millikan found that the charge of an oil drop was always a multiple of 1.6 times 10 to the negative 19 coulombs, no? So, yun yung kanina kong in-explain dito, no? Sa table. So, he concluded that this value is the charge of one electron. Okay? Itong 1.602 times 10 to the negative 19. Yun yung charge of one electron. So, tapos, Thomson had already measured the electron charge to mass ratio, di ba? Sa previous niya. So, nauna niya makuha yun. So, yung value nun is 1.759 times 10 to the 11 coulombs per kilogram. So, if we combine, no, yung charge na nakuha ni Millikan tapos yung charge to mass ratio na nakuha ni Thomson, makukuha natin yung mass ng electron, which is ito, 9.107 times 10 to the negative 31 kilogram. So, yan. Galing, no? Paano na na-discover, no? Through a series of experiments, no? And observations from different scientists, no? Na nag-agree with their findings. Okay. So, moving on, no? After na-discover yung electron, so scientists needed a model for where the electrons were located, no, inside the atom. So Thomson proposed a plum pudding model sa letter A. And dito daw, yung electrons are embedded in a diffuse positive material. So it is like raisins in a pudding. Kaya siya plum pudding. And then Nagaoka, no, propose a Saturn-like model where electrons move around a positive center. So these models were important steps, but they were not the final answer. So Rutherford's experiment would change the picture dramatically. So sino si Rutherford? So Ernest Rutherford and his co-workers performed the gold foil scattering experiment. So they aimed a beam of alpha particles. Okay. So itong symbol na to ay, ito dapat siya, alpha. Okay. Alpha particles, they aim a beam of alpha particles at a very thin piece of gold foil or very thin sheet of gold foil. So, ano yung alpha particles, no? Alpha particles are positively charged particles. So, around the foil was a screen that would briefly glow when hit by an alpha particle. So, the question was simple, no? What happens when positive alpha particles pass through atoms? Okay? So, ito yun. So the results was surprising actually. Most alpha particles pass straight through the gold foil, tumatagos derecho. Some were deflected slightly. So, yun yung mga nandyan. Few particles were slightly deflected. Yung iba tumagos lang diretso. So, a very small number were deflected strongly. No? Ito. Significantly deflected. Pabalik. Or behind the gold foil. So, if the atom were a soft, diffuse positive cloud, katulad na sinasabi ni Thomson, this strong backward deflection would be difficult to explain, no? So, yung pag-deflect niya backward, parang nadi-disprove ng plum pudding model. So, the data suggested that the positive charge and most of the mass of atom were concentrated in a very small region. Okay? Doon nila yun na-observe. Yung parang initial hypothesis nila. So, Rutherford concluded that most of the atom is empty space. Okay? So, that explains why most ARPA particles pass through the gold foil. No? Tumagos lang diretso. So, walang tinamaan. He also concluded that the atom contains a small, dense, positively charged center na tinawag niyang nucleus. Okay? Nucleus. So, the nucleus contains most of the atom's mass and the electrons are outside the nucleus. So, later, the positively charged subatomic particles in the nucleus was called the proton. Okay? So, tingnan natin itong nuclear model, no? So, this figure shows why most alpha particles are not deflected, no? Kung bakit siya tumagos lang. So, the nucleus is tiny compared to the full size of the atom. So, most alpha particles pass through the large electron region without coming close to the nucleus. Okay? So, kaya nga siya tumagos. But if an alpha particle passes near the positively charged nucleus, yan, so it is repelled and yung pathway niya, no, nagbend, no? From here, tumama sa nucleus, bumalik. Tapos ito yung kanina sinasabi, doon lang sa empty space nag-pass through. Okay? So, if it approaches very closely, so the deflection can be large, no? Kapag mas malapit siya dun sa center, no? So, yun lang yung pinapakita nitong experiment nila. Okay? So, yun yung discovery ng proton. So, two more discoveries completed the basic picture ng ating atomic model. Okay? So, si Frederick Soddy of England, showed that atoms of the same element can have different masses. So, these are called isotopes. Okay? So, isotopes have the same number of protons. Tandaan nyo, no? Same number of protons. And different numbers of neutrons, no? Same protons. Different neutrons. Okay? So, later on, James Chadwick naman discovered the neutron in 1932. So, neutrons are uncharged. Ano ito yung neutrons? Uncharged subatomic particles. Okay? With a mass approximately same as the proton daw. So, like protons then, neutrons are found in the nucleus. Okay? So, yun na, nakompleto na yung mga subatomic particles na alam natin ngayon. So, we move on to 2.3, which is the atomic structure and symbolism. Okay? So, by the end of this section, we should be able to write and interpret atomic symbols that shows yung atomic number, mass number, tsaka charge, no? So we should also define the atomic mass unit and average atomic mass, and makalculate yung average atomic mass or isotopic abundance. So this section is very important, no, because it gives us the notation used throughout chemistry, kaya din siya highlight dito sa first parts ng ating reference. So, yun nga, an atom, no? Ito yung atom. No? An atom has a very small nucleus that contains most of its mass. Okay? So, this is because protons and neutrons are much heavier than electrons. So, the electron, although very light, occupy most of all the atom's volume naman. So, a typical atom has a diameter of around 10 to the negative 10 meters. So the nucleus is about 100,000 times smaller. Okay? Around 10 to the negative 15 meters. So the atom is mostly empty space talaga, no? But its mass is concentrated in the nucleus. So ito yung figure kanina, no? Indicating yung nucleus. So this analogy helps us, no? Imagine yung scale. So if an atom were enlarged to the size of a football stadium, so imagine nyo daw yung atom, football stadium siya, yung nucleus would be about the size of a blueberry doon sa sentro ng stadium. So imagine nyo yung laki ng space, no? Between the blueberry and yung pinakalabas ng blueberry, ay nung stadium, no? So that is how small the nucleus is compared to the whole structure, no? Atom, no? But even though na maliit siya, no? It contains nearly all the mass because yun nga, nasa kanya yung protons tsaka neutrons. Okay? So atoms and subatomic particles are extremely small. So a carbon atom weighs less than 2 times 10 to the negative 23 grams. Okay, yun yung isang example. So the charge of an electron is less than 2 times 10 to the negative 19 coulombs. So because these values are so tiny, chemists use special units, no? So for mass, we use the atomic mass unit, or AMU. So 1 AMU is equal to 1.6605 times 10 to the negative 24. So dapat naka-ano yan? Naka-raise yan. So let's rewrite this first. So ito ay times 10 to the negative 24 grams. Okay? So a carbon atom or a carbon-12 atom has a mass of exactly 12 AMU. Okay, so for charge, we use the fundamental unit of charge, E. Ito yun, E. Equal to yung sinabi ni Millikan, 1.602 times 10 to the negative 19 coulombs. So let us compare the three main subatomic particles. So a proton is located in the nucleus, has a mass of about 1.0073 AMU, and a charge of +1. A neutron is also in the nucleus, has a mass of 1.0087 AMU, slightly heavier than the proton, and has no charge, no? 0. So an electron naman is outside the nucleus, has a much smaller mass of 0.00055 AMU. So, and ito naman ay may charge ng -1. So, for most introductory calculations, protons and neutrons count strongly towards mass, and yung electrons naman mainly determine the charge and chemical behavior. Okay? So later on malalaman nyo bakit Yung electron yung mag-determine ng chemical behavior ng isang compound, no? Or atom. So, the atomic number, okay, ibaba natin ng konti. So, atomic number represented by the symbol Z or Z is the number of protons in the nucleus, okay? So, this number defines the identity of the element. For example, any atom with 6 protons is carbon. So, it does not matter how many neutrons or electrons it has, okay? So, if it has 6 protons, it's carbon, period. So, if the number of protons changes, the element changes, okay? Neutral atom has no overall charge naman. So, that means the number of positive charges is equal to the number of negative charges. So, since protons are positive and electrons are negative, a neutral atom has equal numbers of protons and electrons. No? So, therefore, for a neutral atom, the atomic number also tells us the number of electrons. Okay? So, wala namang nagbago kasi dun sa kanyang number of protons and electrons. Okay, let's move on to mass number, no? The mass number represented naman by the symbol or letter A. So this is the total number of protons plus neutrons in an atom. So atomic number Z equals the number of protons. Ulitin lang yung kanina, no? So mass number A is equal to protons plus neutrons, okay? So therefore, yung difference nila, so the number of neutrons is A minus Z, okay? So this is simple but very important formula, no? Neutrons equals mass number minus atomic number, okay? So when the number of protons naman and electrons are not equal, the atom has a net electrical charge, okay? And it's called an ion na when may charge. So the charge is calculated as the number of protons minus the number of electrons, okay? So atoms become ions by losing or gaining electrons. So ito yung kanina kami na-mention na in ordinary chemical change, so the number of protons does not change, okay? Yung, kasi pag binago mo yung number of protons, anong mangyayari ulit? Bagong element na siya, no? Hindi na siya yung same element kanina na originally, no? Okay. So if an atom gains electrons, it becomes negatively charged, no? Siyempre negative eh, no? Nag-gain ka ng negative. So negatively charged, which is yung charge na electron. So a negatively charged ion is called an anion, okay? Tawag sa kanya an ion pag negatively charged. Okay? For example, oxygen has atomic number of 8, no? Z niya is 8. So a neutral oxygen, no, walang charge. A neutral oxygen atom has 8 protons and 8 electrons. So if it gains 2 electrons, no? Pag nag-gain siya ng 2 electrons, it has 10 electrons na and a charge of, ano kaya yung magiging charge niya? No? 8 minus 10 is 2 negative, no? Or 2 minus. So if an atom loses electrons, it becomes positively charged naman. Okay? So kanina, if it gains electrons, it becomes negatively charged. So if the atom loses naman, so i-highlight mo natin to, gains 1 or more electrons. So ngayon naman, if an atom loses 1 or more electrons, it will exhibit a positive charge and tawag na sa kanya ay cation. Okay? So, sodium has 11 electrons, no? And 11 protons, no? Pag neutral yung state niya. So, if it loses 1 electron, no, from the 11, so, it has 10 electrons and a charge of, ano kaya magiging charge niya? 11 minus 10, di ba? So, magiging 1 plus yung charge niya or 1 positive. So, ganun lang malalaman kung ano siyang type ng ion, no? Kung anion or cation siya. So, an ion, negative, cation, positive. So, this figure connects ions and isotopes to help, no? So, iodine is needed for thyroid hormone production. So, a lack of iodine can cause enlargement of the thyroid gland, no? Called goiter, no? May mga goiter, mayroong lack of iodine, no? So, iodized salt contain iodine in ionic form, helping prevent iodine deficiency. So, this is a good reminder that atomic symbols and ions are not just, hindi lang siya notation, no? They describe substances that have real biological importance and application. Okay? So, yung iodized salt may ionic iodine siya. Okay. So, let's proceed with chemical symbols, no? So, a chemical symbol is an abbreviation of an element or an atom of that element. So, for example, Hg and represents mercury. So, some symbols come from the English name while others come from the Latin or other historical name, no? Depende yan. So, most symbols have 1 or 2 letters. So, the capitalization rule is very important, no? Pagdating sa chemical symbols. Only the first letter is capitalized, no? For example, pag cobalt, wait lang, sulat natin. So, for CO pala, CO, so, madali. Ito. CO, capital C, small o means cobalt. Excuse me. But capital C tsaka capital O means ito ay carbon monoxide. Okay? So, this is a compound of carbon and oxygen. So, malaking difference yun, no? Kapag yung capitalization. Yan. The symbol Hg can represent the element mercury in general. So, a large sample of mercury or 1 atom of mercury. Siyempre, depending on context. So, this is common in chemistry naman. Symbols are flexible, but we must understand that they mean in a given situation. No? Dapat natin maintindihan what they mean in a given situation. So, in a bottle label, makikita niyo dito, no? Hg means the sample contains mercury. Okay? So, in an atomic discussion, Hg may mean 1 mercury atom, no? Pagdating sa mga discussion or computation. Okay? So, itong table na to, least common, ito yung nag-list ng mga common elements, no? And their symbols. So, many symbols are straightforward naman, such as ito, carbon, yan, straightforward naman, carbon IC, oxygen, IO, yan, hydrogen is H, saan yung hydrogen? Ito. Yan, tapos meron pa yun, nitrogen, yan, mga basic, no? So, some symbols naman are historical. For example, iron is Fe. Bakit kaya siya Fe? So, it's from the word ferrum, no? So, copper din, usually ito yung mga nasa metal part. From cuprum, gold from aurum, so historical yan. Okay. Sodium, yan. Natrium, yung pangalan niya dati. So, potassium, kaya siya K is kalium, yan. Yan yung mga historical. Ito pa iba, lead. Kaya siya PB, plumbum. Plumbum, dun sa reference niya. Or sa origin niya. Tin naman, SN. Ba't kaya SN, no? Kasi so, from stannum, no? Yun yung tawag sa kanya dati, no? So for this, no, for you students, no, these historical symbols must be memorized, no, because they appear frequently sa formulas tsaka sa mga equation, no, lalo na kayo mga BS Chem majors. Okay, so an isotope naman is written by placing the mass number as a superscript to the left of the element symbol. So sometimes the atomic number is written as a subscript to the left. For example, yung magnesium, no, dito has isotopes magnesium 24, 25, 26. Yan. All magnesiums have 12 protons. What differs is yung neutrons, no? Number of neutrons nila. So magnesium 24 has 12 neutrons. Magnesium 25 has 13 neutrons. Magnesium 26 has 14 neutrons. Okay? So applicable yan sa iba pang isotopes. So ito, simplified. So this slide shows the full atomic symbol format. Okay? So, the element symbol identifies the element. Saan yun? Ito, element symbol. The element symbol identify the elements. Ito yan. Okay. So, the left subscript is for the atomic number Z. Okay? Ito yun. Z. Dyan. So, the right superscript is the charge if the species is an ion. Okay? So, ito yung charge kapag ion siya. When reading this notation, always identify protons from the atomic number. Okay? And neutrons from A minus Z. Okay? And yung electrons naman malalaman nyo dun sa charge, no? Kung nag-gain siya or nag-lose siya ng electron. Okay? Yan. So, hydrogen, for example, has 3 isotopes. So, meron siyang protium, has 1 proton and 0 neutrons with mass number of 1. Deuterium has 1 protons and 1 neutron with mass number of 2. Okay. And tritium has 1 proton and 2 neutrons with a mass number of 3. No? Almost 3. So yun. No? No? So notice that all 3 have atomic number of 1. Yan. Because they all have 1 proton. So their masses and natural abundances differ because the number of neutrons differ. No? So, sinasabi lang dyan na pinaka-abundant yung protium, sumunod yung deuterium, and least yung tritium. No? So, tritium is the radioactive form of hydrogen. So, each proton and each neutron has a mass close to 1 AMU. So, electrons weigh much less. Because of this, the mass of a single atom is approximately equal to its mass number. However, Most elements occur naturally as mixture of isotopes. So the atomic mass listed on the periodic table is not usually the mass number of one isotope, no? It is a weighted average yun of all naturally occurring isotopes of that element, no? So yung nasa nakalista sa periodic table is weighted average ng isotopes ng element na yun. Okay? So the average atomic mass is calculated by summing the products of fractional abundance and isotopic mass for all isotopes. So for boron, 19.9% is boron 10 with a mass of 10.0129 AMU, and 80.1% is boron 11 with a mass of 11.0093 AMU. So convert nyo yung percentage nito to decimals. So yung 19% tsaka 80%. So 0.199 tsaka 0.801. Then calculate 0.199 times yung atomic mass unit plus yung 0.801 times yung atomic mass unit corresponding to that percentage, 11.0093. Yung sum niyan is ito, 10.81 AMU. This is why kung i-check nyo yung periodic table nyo, it shows that boron has an average atomic mass around 10.81, no? Not exactly 10 or 11, no? So ganyan siya computed. So dito papakita sa inyo isa sa mga advanced analytical techniques. So how do we know, no, isotopic masses tsaka abundances, no? So one important method is mass spectrometry. So in mass spectrometry, a sample is vaporized and exposed to high energy electron beam. Okay? So this causes atoms or molecules to become charged, often by losing electrons and becoming cations. So these charged particles are then separated based on their mass to charge ratio, no? So yung resulting pattern, it tells us what isotopes are present and their relative abundances. Okay? So ano yung mga yan? For example nito. Yan. So this figure shows a mass spectrum for zirconium, no? Zr. So each peak corresponds to an isotope of zirconium. Yan, makikita niyo yung mass to charge ratio sa x-axis. Y-axis is relative abundance. So the position of the peak is related to the mass, tsaka yun nga, relative abundance. And the height or intensity ng peak na yun, ayan, ito, yung height niyan, height niyan, height niyan, height niyan. Yun, related siya sa kanyang abundance. Okay? So a mass spectrum is like a fingerprint for isotopes. So it shows that an element may contain several isotopes, not just one kind of atom. Okay? So we now move to chemical formulas. Okay? Our goal dito is to use molecular formulas and empirical formulas, no? To know the difference between them, tapos interpret structural formulas, define the mole and Avogadro's number, and perform calculations that connects mass, moles, atoms, and molecules, no? So this section will bring together yung mga lessons about symbolic chemistry and quantitative chemistry. So a molecular formula tells us the types and numbers of atoms in a molecule or compound. It uses chemical symbols for the elements and subscripts to show how many atoms of each type are present in that compound or molecule. So if there is only one atom of an element, yung subscript niya ay 1 o kaya hindi na sinusulat. It is not written anymore Structural formula naman gives the same composition information, but it also shows how atoms are connected to each other. Okay, so this is important because the same atoms can sometimes be connected in different ways. Okay, so methane can be a representative um, by these figures, no, or drawings. So the molecular formula CH4 tells us that methane has one carbon and four hydrogen atoms, no? So itong sa letter A, yun lang yung information na makukuha natin. It has one carbon and four hydrogen atoms. Yung structural formula naman, itong letter B, shows how hydrogen atoms are connected to carbon, no? So makikita natin yung connection. And itong letter C naman, no? Yung ball and stick model gives a three-dimensional representation of bonds and position, kung paano sila naka-model geometrically, no? And then yung space filling model shows the approximate volume occupied by atoms, no? So ito yung space filling model. So each representation may mga kanya-kanyang purpose yan, and as chemists choose the one that best supports yung discussion na ginagawa namin, no? Okay, so many elements exist as individual atoms. So, yung iba naman, some elements naman, naturally exist as molecules. So, the common diatomic elements are these ones, no? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So, tawag sa kanila ay diatomic molecules. So, yun yung mga formula nila. Nakikita nyo naman dyan. And yung useful memory aid dito is the group of 7 diatomic elements, no? So, sulfur commonly exists as S8, no? Meaning, one molecule contains 8 sulfur atoms. So, ito namang figure na to shows yung elemental sulfur as S8. So the the formula tells us that one sulfur molecule contains how many sulfur atoms? 8, no? Makikita natin dito na mayroon siyang 8 sulfur atoms. Tapos yung structural formula, ball and stick model, tsaka itong space filling model niya, it all represents the same molecule, no? Nakikita niyo naman. But each representation highlights yung different level ng information, katulad nung pinakita natin kanina sa methane. Yung main point natin dito is that even an element can exist as a molecule made of multiple atoms, no? Hindi lang isa or hindi lang dalawa, katulad ng diatomic. Pwede rin ganito in the case of sulfur. Okay. So this slide is very important naman for symbols and formulas. So, H means one hydrogen atom, yan. And 2H means two separate siya, no? Two separate hydrogen atom. Pero itong H2, yan, H2, ang ibig sabihin yan is one hydrogen molecule, no? Containing two bonded hydrogen atoms, no? So, dapat ma-distinguish nyo, no? Yung different ng kapag merong coefficient sa unahan or meron ditong subscript. Okay? Yung last is, ito, 2H2, meaning two hydrogen molecules, bonded together, pero dalawa rin yung instance niya, no? Which means 4 hydrogen atoms total. Okay? So, yan siya. And then, yung coefficient, yun nga, sinasabi ng coefficient, yung coefficient yun yung nasa unahan. Okay. Ito yung coefficient, no? Yung coefficient, sinasabi niyan is, it tells us how many units we have, no? Then, yung subscript naman, yan, subscript. It tells us naman how many atoms are inside one unit. Okay? Lagyan natin yun, no? Subscript tells us how many atoms are inside 1 unit. Tapos yung coefficient, to coefficient naman tells us how many units, no? Units we have. Okay? Hopefully malinaw yan sa inyo. Okay, next. So, pagdating naman sa empirical formula gives us the simplest whole number ratio of atoms or ions in a compound. Okay? So, a molecular formula gives us the actual number of atoms in a molecule. Yun yung difference ng dalawa, no? So, for benzene, the molecular formula is C6H6 because the 6:6 ratio simplifies to ulit. So, yung benzene yung molecular formula is C6H6. Ito. Okay, ano yung empirical formula niya? So, empirical formula niya is CH. So, sinisimplify nito yung 6:6 ratio ng carbon to hydrogen to 1:1 na lang. So, another example natin is yung acetic acid, which has a molecular formula of C2H4O2. Then yun nga, i-divide nyo lang yan sa simplest whole number, no, ratio na pwede, which is 2. Pag dinivide mo yan sa 2, lahat ng subscript, ang magiging empirical formula is CH2O. No? So, yung 2 to 4 to 2 na ratio, sinisimplify niya to 1:2:1. Okay? So, ganun lang is empirical formula. Okay. Let's talk about titanium dioxide, no? Ang empirical formula ni titanium dioxide is TiO2. Okay. So, this tells us that titanium and oxygen are present in a 1:2 ratio. Okay. So, the figure also connects chemistry to a familiar application, no? So, titanium dioxide is used in white pigments and in sunscreen. Usually, makikita niyo sa sunscreen nyo. Because its ability to block light, no? So, formula notation gives us the composition behind the material. Next. So, benzene ulit. Balik tayo kay benzene, no? Kanina, formula niya is, ano yung molecular formula niya? C6H6. Tapos, yung empirical formula is CH. No? So, yung actual molecule contains 6 carbon atoms and 6 hydrogen atoms. Yung structural formula tsaka models, it shows us that the atoms are arranged in a, ano kayong fashion yan? Ring fashion, no? Para siyang ring. No? Naka-ring siya. So, it also reminds us, no, ditong slide na to na yung empirical formula are simplified ratios. Samantalang yung molecular formula describe the actual molecule. Okay? So, vinegar contains acetic acid. So, naman tayo kay acetic acid. So, ang molecular formula kanina, no? Binanggit natin C2H4O2. So, if we divide the subscript by 2, makukuha nga natin yung kanyang empirical formula, which is CH2O. So, example naman ito, useful to because it shows that two formulas can describe the same substance, no? Pero at a different level, no? Yung molecular formula gives you actual form, actual atom counts, no? Exact atom counts niya. Pero yung formula, yung empirical formula is magbibigay lang ng simplest ratio, no? Okay. So, sometimes, ito pala sino to? Chemist Lee Cronin. So, itong chemist na to, yung research niya nag-focus on complex chemical systems. Ano pa? nanoscience, solar fuels, synthetic biology, and artificial life. So, yung connection nito sa topic natin is that yung mga chemist, no? Nagdi-design tayo, nagbi-build din tayo, at tinatry natin ma-understand, no? Yung iba't ibang molecules. And to do that, we must know yung mga formulas, structure, paano nagko-connect yung mga atoms together, no? So before we can design or build or understand molecules, dapat alam natin yung basic foundation or concepts ng mga ito, mga discuss natin, no? So yung basic notation dito is that we learn here yung basics muna bago tayo mag-advance sa molecular design. So yung mga molecules, dinidesign din yan, no? Okay. So sometimes naman, the same atoms can be arranged in different ways. So compounds with the same chemical formula but different molecular structures are called isomers. Okay? So ulit natin yun, no? So compounds with the same chemical formula but different molecular structures. Okay? Isomers ang tawag dun. So, for example, ayan, makikita natin dito si acetic acid and methyl formate. Parehas sila ng molecular formula na C2H4O2. Okay? Si acetic acid at si methyl formate. But they have a different structures and properties. So, punta tayo sa next slide. Makikita nyo yung sa figure, no, yung structure ng acetic acid tsaka methyl formate. If we count, no, yung carbon atoms, you have here 2, you have here 2 hydrogen atoms, 1, 2, 3, 4. Dito naman 1, 2, 3, 4. And oxygen we have 1, 2, 1, 2. Okay? Pero iba yung structure niya, no? Pero parehas sila ng formula. So these are isomers, okay? Kasi same formula but different structure, okay? Iba yung arrangement, no? Or bonding ng mga atoms niya. So in acetic acid, the molecule contains a carboxylic group. So sa organic chemistry, matututunan nyo ano yung carboxylic group. So ito yung part na yun, no? Carboxylic group. Ngayon natin dito. Nakalagay sa slide. Carboxylic group. And then, sa methyl formate naman, one oxygen is placed between carbon atoms. Okay? So, this is an ester arrangement, no? ROR. Ito yun. So, this is ester. Maganda lang natin. Arrangement. So, yan. So, because structure affects yung properties talaga ng ating mga chemicals, no? So, nagbabago yung chemical properties based sa structure ng mga atoms. So, these two substances behave differently, no? Iba ang carboxylic acid sa ester, no? Nagkaiba sila ng function, no? Properties, function, everything. Pero parehas ng formula. Okay? So ito, this slide shows naman another type of isomerism. So, tinatawag siya na, meron ba dito? Spatial isomers. Okay? Spatial isomers. Hindi special, no? So, the molecules of carbon differ in the orientation of atoms in space naman. Even though the connections are similar. Makikita nyo siya na meron tayo dito plus carbon tsaka minus carbon, or tinatawag namin ito na S isomer tsaka R isomer ng carbon. Kaya siya meron ditong label na S tsaka R. So, parehas yung connection yung mga yan. Makikita nyo. Pero iba yung orientation sa space. So, may effect din yan, no? So, yung isang form nito is like caraway. Tinatawag na ng caraway. While other, yung kabilang form naman smells like peppermint. Ay, peppermint. Spearmint pala, sorry. Spearmint, no? Nagkaiba sila ng um, scent, no? Nagkaiba sila ng scent. So, this is a powerful example, no? Showing that yung molecular shape, nagmamatter din siya, no? Chemistry is not just about na-drawing mo tong atom na to, ano yung nire-represent itong atom na to. It also shows na how atoms are arranged and paano siya nagbabago ng properties, no? So, ito yung spearmint, ito yung caraway. Magkaiba sila ng amoy. Okay, next natin, yan. Papalapit na tayo sa computations. So, yung mole naman, tinatawag na mole, no? This is an amount unit, no? Just like yung dozen, gross amount, or pair. So, it's a unit, no? So, a dozen means, ano yung sabihin ng dozen? 12 objects, no? Or 12 pieces, ganun. So, yung mole naman, ang ibig sabihin nito ay, wala ba dito nakalagay? Wala. So, ang ibig sabihin nito ay 6.022 times 10 to the 23 objects, no? Or pieces, no? So, mole is or means 6.022 times 10 to the 23, no? Object. Sabihin na natin object or pieces, ganyan. Pero, in reality, atoms talaga siya, no? Atoms per molecule. So, the objects can be, yun nga, sinabi ko na, atoms, molecules, ions, or formula units, no? So, the mole is defined in relation to carbon-12 and provides yung bridge between the microscopic world of particles and the macroscopic world of grams, no? Which can be measured sa laboratory. Okay? Yan na. Dito naman pala siya. So, the number of particles in 1 mole is Avogadro's number. Yun yung tawag sa kanya. So, we usually use the rounded value, no? Itong part na to. Yan. Pero ito talaga yung actual value niya, no? So, that is 6.022 times 10 to the 23 particles per mole. So, 1 mole of carbon atoms, natin, no? 1 mole of carbon atoms and 1 mole of sodium atoms contain the same number of atoms, okay? So, however, their masses is nagbabago or yung masses nila ay different because carbon atoms and sodium atoms have different atomic mass, no? So, 1 mole always mean the same number, no? Same number of particles, pero hindi siya necessarily same yung mass. Okay? Ayan, makikita niyo dito. So, each sample in this figure contains exactly 1 mole of atoms. Okay? Meaning, each has 6.022 times 10 to the 23 atoms, no? So, mayroong iba't ibang example dyan. Pero, but yung masses nila is different as you can see dun sa indicated mass nila, no? So, 1 mole of carbon is about 12 grams. Then, 1 mole of magnesium is about 24.3 grams. 1 mole of copper is about 63.85 grams. And 1 mole of lead is about 207 grams, okay? So, yung number of atoms, lahat sila merong 6.22 times 10 to the 23 atoms sa isang mole nila. Pero iba-iba sila ng mass, okay? So, yun yung basic understanding natin dyan dapat. So, what is molar mass naman? So, molar mass is the mass in grams of 1 mole of a substance. Okay? Mass in grams of 1 mole of that substance. Okay? Its unit is grams per mole. No? So, very useful to. Very gamit na gamit to sa mga calculations natin. Yung pinaka-idea dito is that molar mass in grams per mole is numerically equal to atomic mass or formula mass in AMU. For example, yan. 1 carbon 12 atom has a mass of 12 AMU, and 1 mole of carbon 12 atom has a mass of 12 grams, no? So yun yung relationship nilang dalawa, no? And this allows us to convert between grams and moles, okay? So the sample idea applies din sa compounds, no? Each sample here sa figure na to contains 1 mole of molecules or formula unit. Ito naman molecule yung pinag-uusapan, no? Hindi na element. So methanol has a formula mass of about 32.0 AMU. So 1 mole of methanol has a mass of about 32 grams. Okay? Tapos sulfur naman, on the other hand, sulfur as S8 has a formula mass of about 256.5 AMU. Okay? And so yung 1 mole ni sulfur, no, has a mass of about 256.5 grams. Okay? So ito yung mga minention ko na yun. Ito yun. Tapos si methanol. Yan. Okay? So, molar mass, nililink niya yung formula mass to grams. No? Basta ang endpoint natin, makakuha tayo ng unit na naka-grams. Okay? So, this table shows that average atomic mass in AMU and molar mass in grams per mole. So, almost makikita nyo, parehas sila ng value, no? So, carbon has an average atomic mass of 12.01 AMU and molar mass of 12.01 grams per mole. So, hydrogen and so on, no? Parehas lang sila ng value. So, every one of these molar masses corresponds to 6.022 times 10 to the 23 atoms. Okay? So, a small droplet of water contains an unimaginably large number of molecules. Okay? So, the figure states that the number of molecules in one tiny droplet of water is around roughly 100 billion times greater than the number of people on Earth. Okay? So, this helps us, no, ma-appreciate why chemists use the mole, no, instead of yung actual numbers. Kasi nga, masyadong madami, no? So, counting particles one by one is impossible. So, we count them through the mass and molar mass para mapadali yung calculations natin. Okay. So, ngayon, we will apply, no, the relationships among formula mass, molar mass, yung mole, tsaka Avogadro's number, no? So, yung basic strategy natin dito is yung tinatawag na dimensional analysis, no? So, sulat ko na dito, no? Dimensional analysis na tinatawag. So, we start with a given quantity, then multiply natin sa conversion factor. So, mamaya pakita na sa inyo. Magka-cancel tayo ng mga units and we end up with the required unit, no? So, if we know grams, we can find moles. If we know moles, we can find grams, and the other way around, no? So, if we know moles, we can find number of atoms or molecules using yung Avogadro's number. Okay? Yan. So, punta tayo dito. So, according to nutritional guidelines from the USDA, the estimated average requirement for dietary potassium is 4.7 grams. So, sabi dito, what is the average requirement of potassium in moles? Okay? Ano daw yun? So, yung problem, tinatanong niya, ano yung estimated average requirement for dietary potassium, no? Which is 4.7 grams. So, ano yung amount niya in moles? So, we will convert, no? Ang kailangan natin dito is yung molar mass ng potassium galing sa periodic table. So, what's the molar mass of potassium. So, molar mass of potassium, actually nakasulat na dyan, no, is around 39.10 grams per mole, no, ng potassium. Lagyan ko na lang ng K. Huwag na pala. Basta yan. Molar mass ng potassium, yung K yung potassium dito. Okay? Ganyan ko lang siya sinusulat. 39.10 grams per mole. So, to convert grams to mole, we divide it by the molar mass. Okay? Yung grams. So, ito yung parang structure niya. We were given yung mass of potassium, which is 4.7 grams, diba? Dun sa problem. Then, we will use the molar mass, the potassium. We will divide it by that value to get yung moles of potassium, which is in mole. So, sa baba, makikita nyo naman, 4.7 grams, yan, of potassium, divide. So, pag sinabing divide, baka kasi malito kayo, but naging baligtad siya. So, ang original niya is 39.10 grams per mole, no? So, if we divide it by 39, so sa baba na yung 39.10 grams. So, sa taas na yung moles, no? So, parang ni-reverse mo siya. Pero basically, dinivide mo nga siya. So, nabaligtad din yung unit kasi nga dinivide mo siya. So, you have to cancel yung grams, no? Cancel yung grams. Matitira is moles of potassium. So, when you use the calculator, makukuha nyo dapat na sagot ay 0.12 moles potassium. Okay? Yan. Ganun lang siya simple, no? To convert grams to moles. Okay. Another example. Here, 1 liter of air contains daw how many moles of argon? 9.2 times 10 to the negative 4 moles of argon. So, what is the mass of air, AR or argon in the liter of air? Okay? Kung ang liter of air ay may 9.2 times 10 to the negative 4. So, ito yung pinaka-structure niya ulit. And ang molar mass ng argon ay 39.95 grams per mole. Okay? So, dito naman baligtad, no? Kanina we were given yung grams ng material or ng element. So, dito naman meron tayong number of moles ng argon natin, which is 9.2 times 10 to the negative 4 moles of argon, no? So, ang gagawin naman is i-multiply lang natin yung molar mass, no? Dito yung molar mass no argon. I-multiply natin siya to get yung grams ng argon na kailangan natin. So, sa baba, so direct na yan. So, ito yung 9.2 times 10 to the negative 4 multiply. So, nakita natin, no? Pag multiply, hindi natin siya i-reverse yung arrangement niya, no? So, yung kaninang tinatawag na dimensional analysis, you make a way, no? Para yung ending unit nyo ay nasa taas, no? Okay? Katulad ito yung kanina. So, ang ending unit natin is, so you don't have to memorize din naman kung divide ba or multiply. You imagine, no? Kaya nga siya tinawag ng dimensional analysis. Kung saan pwede mag-cancel ng unit. And then you perform yung, kuwari, napunta sa baba yung 39.10 grams kanina. So, you have to divide that, no? Kaya siya dimensional analysis. So, dito naman, as is yung molar mass ng ating argon. So, nasa taas pa rin si 39.95 grams. Nasa baba yung per mole niya. Then we get, no? Pag minultiply natin, makukuha natin yung sagot na 0.037 grams of argon. So, meron daw 0.037 grams of argon sa liter ng air sample na nakuha. Okay? So, ito naman, makikita nyo, no? Yung unit na kinancel, tapos yung ending unit ay nasa taas. No? Ending unit nasa taas. So, yun yung tinatawag na dimensional analysis. Okay? Okay, next natin. Yan, next na figure. So, copper wire, pag tinignan natin siya, no, it looks continuous sa ating mga mata kasi nga wire siya, no? but it is made of many copper atoms. Okay? So this figure prepares us for the next type of calculation, no? Wherein we will convert yung measured mass of an element into a number of atoms, no? So to do that, we need two conversion steps. So we have to do grams to moles using molar mass and moles to atoms using Avogadro's number. So paano natin siya gagawin, no? So ito yun, we have a mass, given mass ng ating atom, which is copper atom. We divide by the molar mass to get the moles of copper atoms, and we multiply by the Avogadro's number, no? To get the number of copper atoms in that given mass, no? Ng ating sample. For example, we have 5 grams of copper. Okay? So, ano ang molar mass ng ating copper? So, molar mass of ating copper ay, dito ko na nalalagay sa baba, we have 63.55 grams per mole copper. Okay? So, to do the conversion, no, susundan na lang natin siya afterwards. So, we have here grams copper. We have here atoms, no, moles copper. So, we have Avogadro's number. Yan. And then we will get, no, number of atoms. So, unit na lang yan. So, copper atoms. Ganyan. So, we have 5 grams. Example ko lang to, no? So, ito yung molar mass ng ating copper atom. Okay. So, paano natin siya gagawin? So, 5.0 grams copper. So, we will divide daw by the molar mass. So, mare-reverse yung ating unit. So, 1 mole of copper ay merong 63.55 grams of copper. Usually ako, pag nagsusulat ako, inuulit ko yung kung anong element siya, inuulit ko siyang isulat. Okay? So, preference ko lang yun. Para pag nag-cancel ako, hindi bigla mawala yung symbol. And for that, we will get na yung moles of copper. Tapos daw, we will multiply with Avogadro's number, 6.022 times 10 to the 23 atoms per 1 mole copper atoms. Yan, no? Sige, baliktarin ko lang. Yan. Copper atoms per 1 mole of copper. Ano pang next na gagawin? Wala na, no? So, we cancel yung units, no? So, grams of carbon, grams of carbon, grams of copper, moles of copper, cancel yan. Okay. So, to that, we will give, pag inano siya, so magiging 5 times 6.022 times 10 to the 23 divided by yung 63.55. Dapat ang makuha nyo sagot dyan ay 4.74 times 10 to the 22 copper atoms. Okay? So, imagine niyo, no, sa 5 grams ng copper wire, meron tayong almost 4.74 times 10 to the 22 billions nga siya of copper atoms. Okay? So, ganyan lang siya. Dimensional analysis, no? Ganyan lang siya ginagawa. And nakadepende sa goal, no? Kung ano yung given, nakadepende sa given din, tsaka kung ano yung hinahanap, no? Kung paano nyo siya gagawin. Okay? Let's move on sa isa pang example. Yan. So, now we apply naman, no, the same grams to mole idea sa compound naman, no? Paano pag compound yung given? Kanina kasi copper lang, madali lang, no? So, the compound glycine, itong C2H5O2N, yun yung formula. We are given a mass in grams and tinatanong yung moles, no? Given sa mass na yun. So, yung path niya, simple lang naman. Pinapakita dito sa figure na to. Simple lang naman siya. the mass of glycine in grams divided by the molar mass of glycine in grams per mole, no? It will give us moles of glycine, no? So yung main extra step dito is that we must first compute the molar mass from the formula, no? So punta tayo ngayon sa next slide. Ayan. So medyo mahaba itong process na to, pero dapat makuha nyo siya since may periodic table naman. So for glycine, yan, C2H5O2N, no? So yun yung mga elements niya. We have carbon, hydrogen, oxygen, nitrogen. So calculate the molar mass by adding yung atomic contribution, no? So 2 carbons, 5 hydrogen, 2 oxygen, 1 nitrogen. I-multiply natin siya sa individual molar mass ng mga element na yun. For carbon, 12.01 and so on, no? Yan na yung mga molar mass. So upon multiplying, makukuha tayo ng subtotal, no? So for the subtotal, ito yan. Subtotal for carbon, 24.02. For hydrogen, 5.040. Oxygen, we have 32. And nitrogen, we have 14.007. Tapos, pag kinuha mo yung sum niya mga yan, makukuha mo itong 75.07, no? So, that will be the molar mass of C2H5O2N, no? 75.07 grams per mole. So, ganyan kumuha ng molar mass pag compound yung given. Then, we proceed with the same calculation, okay? Suppose that meron bang given? Wala naman, no? Suppose na meron tayong given to, no? Kunwari, meron tayong 28. So, lagay natin dyan. This is given. Example. Given mass of glycine. So, yun yung example. Given mass of glycine, 28.35 grams. Then, we divide, no? Base dito, no? We divide daw. Tapos yun nga, dimensional analysis pa din. No? Not necessarily di ko kasi masyadong binabanggit kung multiply or divide. Basta minamanipulate ko yung molar mass into yung ending unit na kailangan ko. No? Ganun ako mag-approach ng ganitong problem. So, grams of glycine cancel. So, 28.35 divided by 75.07 na siya. So, dapat ang makuha nating sagot ay ito. 0.378 moles of glycine sa 28.35 grams of glycine. Okay? So, more examples. Yan. So, vitamin C has a molecular formula of C6H8O6. So, yung recommended daily dietary allowance daw for children age 4 to 8 years old is ito, 1.4 times 10 to the negative 4 moles. So, for example purposes na to. Pero usually, di naman ganyan sinasabi ng doktor, no? Kapag nag-prescribe siya. So, yun daw yun. So, ano yung molar mass ng ating vitamin C? So, binigay naman dito, no? 176.124 grams per mole ang molar mass ng ating vitamin C. Then, to compute or to convert yung moles sa grams, okay, we multiply it by the molar mass ng ating vitamin C. Therefore, ang given natin ito, 1.42 times 10 to the negative 4 moles of vitamin C times its molar mass, no? Which is 176.124 grams of vitamin C per 1 mole of vitamin C. So, for that, we need dapat ang makuha natin is 0.0250 grams vitamin C. So, yan ang prescribed daily dietary allowance ng vitamin C for children age 4 to 8 years old. Okay? So, ganun lang siya simple, no? Okay. So, another example ulit. So, in this example, so, a packet of artificial sweetener, yan, mga mailing artificial sweetener dyan, it contains 40.0 milligrams of saccharin na tinatawag, no? Ito yung formula ni saccharin. C7H5NO3S, no? And ang kanyang molar mass ay 183.8 grams, no? Given that ito yung molar mass niya, tinatanong sa atin, how many saccharin molecules are there doon sa 40 milligram, no? Dito convert niya 9 grams. So, how many carbon atoms are in the sample? Ang daming tanong, no? So, how many molecules of saccharin molecules doon sa 40 milligrams? Tapos, ilan daw yung carbon atoms, no? Okay. Let's compute for that. So, ito, isa-isayin natin siya. So, we have yung mass, no? So, pag mayroon mga mass na given sa inyo, iba yung unit, kung rin naka-milligrams. So, you have to convert it to grams, no? Kasi ang ating molar mass ay naka-grams per mole, no? So, we have here, ito yung grams ng saccharin natin. Tapos, ito yung molar mass ng ating saccharin. Okay? Tapos, ito ay Avogadro's number. Okay? So, given the mass, we divide by the molar mass of saccharin, which is ito, part na to, and we multiply by the Avogadro's number, no? To get the number of saccharin molecules, which is, dapat ito yung makuha natin. So, sa 40 milligram, so lagay ko lang dito, no? From 40.0 milligram, convert to grams. Okay? From that, meron daw siyang 1.31 times 10 to the 20 saccharin molecules. Okay? So, from that saccharin molecules, pinapahanap din kung ilan yung carbon atoms, no? So, alam natin dun sa formula, based sa formula, no? Ito ay based sa formula C7H5NO3S. Wait lang, mukha siyang saburin ko lang siya. H5NO3S. So, meron tayong 7 carbons sa isang molecule. Ito ay, yan, biglang ito bago sa inyo, no? So, this is a conversion factor lang, no? So, parang ano to, common sense naman ito. So, sa isang molecule, ilan ba yung carbon atom? 7, no? Kaya meron 7 carbon atoms. So, for that, we just have to multiply yung nakuha nating number of molecules ng saccharin sa number of carbon atoms, no? Which is 7. Therefore, makukuha nating sagot dapat is 9.17 times 10 to the 20 carbon atoms. Okay? Hopefully, you got that. And then, some applications lang. So, this figure begins an application in neuroscience, no? So, typical human brain daw weighs for about 1.5 kilograms and has a volume of roughly 1.1 liters. So, brain tissue contains specialized cells called neurons, no? And mga neurons. So, these cells transmit information through electrical and chemical signals. So, chemistry becomes important because chemical signaling depends on molecules being released, received, and counted, no? So, imagine nyo, no, kung gaano ka-specialize yung body natin, overall humanity natin, especially dito, no, sa brain, no, sa activity ng ating brain. So, alam niya kung gaano kadami, gaano kakonti, gaano karaming kakonti yung nilalabas or nire-receive ng ating kailangan ma-receive ng ating katawan, no? In the different brain activities, no? So, sa ganun ka highly specialized yung ating katawan, no? Pointing to our creator, no? So, very, very, magandang siya. Dito? Appreciation, no? Kung paano tayo na-design. Okay. So, speaking of, yun nga, sa brain activity, so, paano nga ba nagkakaroon or ano nga ba nangyayari, no? So, yung chemical signals, natatransmit yun when yung neurons natin, yan, neurotransmitters. So, nagre-release ang ating neurons ng neurotransmitters, no? So, molecules yung mga yun into a small gaps called synapses, no? And then, one important neurotransmitter is tinatawag na dopamine, no? Ito yun, represented by these molecules. So, dopamine molecules, ang formula niya ay Ch.11NO2. So, using the mole concept, scientists can connect, no, extremely small numbers of molecules to measurable quantities, no? So, this is a good example of how chemical formulas and molecular counting apply directly to a biological process or biological system, no? So, yan siya. Some examples lang yan. So, yun. This is just a summary actually for this chapter. Sige, let's answer exercise 1. So, the starting material shows how many green atoms? 1 green atoms and 2 blue atoms bonded together. And then, the product shows 2. Sige, bilangin natin ito. 1 green atom, dito ay 1, tapos 2. Dito naman ay 1, 2, 1, 2 na blue atoms. Okay? So, count the atoms, no? Dito merong 1 green atom, 2 blue atoms. Kasi naka-blue na ako. 1 green. So, we have here 2 green atoms and 2 blue atoms. Okay? So, magkaiba siya, no? So, that means a green atom appears to have been created during a chemical change, no? So, ang tanong dito is, nag-a-agree ba siya or nag-violate siya sa Dalton's postulate, no? Na yung atoms are not created during chemical reactions. Ano yung sabi? They are only rearranged. So, this one, no, violates Dalton's postulate. Okay? Next. Ano to, mga exercise lang to? Para bago tayo mag-proceed sa next chapter. So, for this one, we write molecular formula and empirical formula from the given structure. So, for part A, sige, sulat natin yan. For part A, the structure is carbon dioxide, no? So, molecular formula niya is CO2, okay? And ang kanyang empirical formula ay CO2 pa din, okay? So, for part B, ang molecular formula nito ay C2H2. Ang empirical formula ay CH, okay? So, gets bakit CH, no? I-divide lang natin sa lowest whole number na meron dito sa ratio nila. So, next natin is C2H4. So, ano ang empirical formula dito is CH2, no? Divide by 2. So, magiging 2 na lang. Magiging 1 sa carbon and 2 sa hydrogen. Lastly, we have molecular formula ito ay, sige, ano siya? H2SO4, sulfuric acid yan, no? Okay, for part D, ano siya? May simplify ba natin siya? So, hindi na, no? Kasi wala siyang common. Parang ano to, sa math, yung kinahanap natin yung least common denominator sa fraction. So, para siyang ganun. So, dito naman, since 1 yung pinakamababa, wala na tayong magdi-dividean, kundi sa 1 lang. So, H2SO4 pa din siya. Okay? Next exercise. So, in here, we will write here yung kanyang molecular formula and then empirical formula. Same pa din naman using the structures given. So, we have here 4 carbon atoms and ilan yung hydrogen? 1, 2, 3, 4, 5, 6, 7, 8 hydrogen. So, ang ating molecular formula here is C4H8. empirical formula, so ang lowest integers dito ay 4. Pwede natin i-divide sa 4 both. So we have CH2 for the empirical formula. For this one, we have 4 carbons ulit and 6 hydrogen. So molecular formula here will be C4H6, while yung ating empirical formula will be, so divide by ano kaya siya? By 2, no? Kasi pag divide mo 4, magkaka-fraction. So dapat walang fraction. Lowest full number lang. So C2H3 ang kanyang empirical formula. So for part C, we have 2 silicon atoms and 2 hydrogen atoms. Wait lang. 2 silicon, 2 hydrogen, ilan yung chlorine? 4 chlorine atoms. Okay? So the molecular formula is Si2H2Cl4. So ano kaya empirical formula nito? So we will have SiHCl2. Okay? Divide by 2 lang. So next, we have here 3 hydrogen, 1 phosphorus, 4 oxygen. So the molecular formula will be H3PO4. So ano kaya empirical formula here? Medyo kakaiba sila ng mga subscript. So wala, no? Ang kanyang lowest ratio ay 1 lang. So we have here H3PO4 for the empirical formula. Okay? Next. Dito naman, ganun din naman, no? So we have, so sunod-sunod lang exercise natin. So determine ulit natin yung molecular formula at empirical formula. So we have here, ilan? 2 carbons, 2 oxygen, 4 hydrogen. Molecular formula nito ay C2H4O2. So this is acetic acid, no? Ano empirical formula ng acetic acid ulit? CH2O, no? Divide by 2. So for part B, we have the molecular formula of, wait lang, bilangin muna natin yung carbon atoms. We have 4 carbon atoms, 2 oxygen atoms, 3, 4, 5, 6, 7, 8 hydrogen atoms. Okay? So molecular formula nito ay C4H8O2. Then for the empirical formula, divide by 2. So 2 yung pinakamababang whole number, no? Na pwede natin pag-dividean. We have C2H4O. Okay? So that's how you get the empirical formula, no? From the molecular formula. Okay? So yung mga conversion, balikan nyo na lang yan. Yan. Important yan sa ating lessons. Lahat naman to important, no? Okay. So yun yung basics ng atoms, molecule structures, and computations, no? Conversions. So we now move on to the periodic table, no? So objective natin dito is to state the periodic law, explain how the periodic table is organized, and predict general element properties from position, and identify yung metals and metalloids, no? So important dito yung predict yung general properties ng elements, no? Based sa location nila sa periodic table. So Dmitry Mendeleev, no, and Lothar Meyer independently recognized that element properties show periodic patterns. Okay? So for example, lithium, sodium, potassium are all shiny daw. Conduct heat and electricity. And they have similar chemical behavior daw, no? Sabi nila. And then, calcium, strontium, barium are also shiny, but they are less reactive than lithium, sodium, and potassium, no? So, yun yung mga simple observation, pero napakalaki ng impact nila. So, Mendeleev and Meyer they arranged the elements by increasing atomic mass. Okay, so Mendeleev went further by using gaps in his table to predict elements that had not yet been discovered, no? So, the later discoveries of gallium and germanium strongly supported yung gawa ni Mendeleev. Okay. So, this figure illustrates the concept, no? So, Dmitri Mendeleev, ito siya. Ayun yung picture niya, no? So, he is widely credited with creating, no, itong periodic table na to, itong version na to, no, sa letter B, no? Ito yung version niya. So, yung main point here is not to memorize yung picture, no, but to connect the visual evidence to the chemical idea that we are developing right now. So, by the 20th century, scientists realized that periodicity depends on atomic number rather than atomic mass, no? Natin difference yung dalawang yan. So, the periodic law states that the properties of the elements are periodic functions of their atomic numbers. So, in the modern periodic table, elements are arranged by increasing atomic number, no? So, horizontal rows are periods and vertical columns are groups. So, ano yung mga yun? So, medyo blurred lang, no? PDF ko na kasi. So, this figure illustrates the concept on the slide, no? Elements in the periodic tables are arranged according to their properties. Okay. So, yun nga. Hindi natin siya memorize. So, ito yung periods. Yan yung periods. Pag ganun. Mali. Group yan. Yan yung group. Wait lang, ulitin natin. Highlight na lang natin ang blue. So, this is group 1. This is group 13. Yan, group 18. And for the period, gamitan natin ng violet kasi siya. So, lagyan natin ng pagka-violet. Okay? So, this is period 1. So, si hydrogen tsaka helium lang yan. Period 4. Ito siya. So, yan. Okay? Yun yung difference ng group and period. So, sa mga modern period, actually modern naman tong periodic table na nandito, no? Ano ba yun? Ano na rin siya, naka-highlight na din siya. Ano yung mga metals, metalloids, non-metals. Pero dadaanan natin siya afterwards. Okay? So, metals are generally shiny, malleable, and good conductors of heat and electricity. While yung non-metals naman, dull siya and poor conductors of heat and electricity. No? So, in between that, metals and non-metals, we have metalloids. So, they have intermediate behavior. No? They conduct moderately and have some properties of metals and some non-metals. Okay? So, the main group elements are in groups 1, 2, tapos 13 to 18. Okay? Main group elements yun. So, ito yung mga yun. So, bring ko na itong highlight. So, main groups element daw ay groups 1, 2, tsaka 13 to 18, no? Main group. So, balik tayo din sa slide kanina. Transition metals, groups 3 to 13. Okay? Groups 3 to 13. Ha? Nag-overlap ba siya? Wait. 3 to 13, no? Sige, ngayon natin dyan. Kasi merong part na may transition metals kasi. So, yan. Okay? And then, we have inner transition metals, no? So, yun yung dalawang rows na nasa baba, no? Ito yung inner transition metals, mostly radioactive, no? Inner transition metals. We have here transition metals. Okay? Okay. So, yun yung groupings nila or classification. Yun yung groupings, no? And then, para mas specific pa, several groups have special names. So, group 1, except hydrogen, are called alkali metals. Group 2 contains the alkaline earth metals. Group 15, tawag siyang pnictogens, no? Parang ko na na-encounter tong pnictogens. Dahil yata sa kanyang arrangements. Anyway, hindi na natin yan masyadong pagtutuunan ng pansin. Pnictogens, group 16 is chalcogens, group 17 is halogens. Usually itong halogens lang yan. Ito, hindi na ito masyadong in-highlight. Pero yan siya, nandiyan siya. Nandiyan yung information for you guys. And group 18 contains the noble gases. Okay? Yan yung sa main group elements. May mga special name siya. Ito pala pinahirapan ko pa yung sarili kong mag-highlight. Pero yan, ito yung organization ng periodic table, no? Okay. So, di nyo naman siya kailangan i-memorize, pero as you go along, since first year pa lang kayo, mamay-memorize at mamay-memorize nyo yan, no? Okay, so that's it for sa periodic table, no? Yun lang yung kailangan nyo munang malaman for now. Arrangement nyo sa periodic table, discovery, and all, no? Now we move on sa medyo in advance natin tong nomenclature because last year kasi, no, medyo nasa further back pa tong nomenclature. Pero marami na ako na-mention na names ng chemicals. So ngayon pa lang, i-discuss na natin siya. So the objective of this part, this last part, is very practical, no? So how do I know ba the name of the compound from the formula? Or how do we write ba the formula from the name, no? So ito yun, no? May systematic rules tayo. Nomenclature rules or naming rules na sinusunod, no? And we will apply those rules sa ionic compounds, molecular compounds, hydrates, tsaka acids. Okay? So, nomenclature simply means a system of naming. So, in chemistry, a compound is identified by both its chemical formula and its chemical name. Okay, so in this part, we will focus on inorganic compounds, binary ionic compounds. So, ano yung mga inorganic compounds na yun, no? Ionic and molecular binary compounds. And ionic compounds containing polyatomic ions, hydrates, hindi na nakalagay dito pero sama natin siya, and acids, no? So, the key skill is recognizing the type of compound, no? Yun muna yung una, no? Recognizing the type of compound first because each type follows a different naming rule, okay? Okay, naming ionic compounds, no? So, for ionic compounds, the rule is straightforward naman. So, name the cation first, then the anion. So, if the cation is monoatomic cation or metal ion such as sodium, calcium, aluminum, so we simply use the element name, okay? So, lagyan natin siya ng example like sodium, calcium, aluminum, no? So, we use the given name of that element. So, if the anion naman daw is monoatomic, so we change the ending, no, of the element to IDE. No? Nalagyan tayo ng IDE kapag siya ay monoatomic anion. Okay? Remember that, ha? Okay. So, for example, mga example ng mga monoatomic ion natin, chlorine, no? So, chlorine, di ba chlorine? So, it becomes chloride. Okay? So, oxygen. Yan. Ano mangyayari sa kanya? Oxide, no? Yung IDE, no? Sulfur. Yan. sulfide. Okay? So, ganun siya, no? Kapag monoatomic anions, no? So, if the ion is polyatomic, no? Polyatomic. So, ito, di ba? Usually, ganyan yung form nila. So, for polyatomic ions, such as nitrate, no? Ang kanyang formula ay ganyan. Nitrate. Ang charge ng nitrate ay negative, no? Lagyan lang natin ng negative. Pero later on natin yung di-discuss. Tsaka sulfate, SO4, 2 minus. For this type of ions, polyatomic ions, hindi natin siya babaguhin, no? Yung name nila is as is. Ganyan pa din. Okay? So, ayan. So, these are, you can use these tables, no, to practice yung basic ionic naming. So, cation name is written first, such as, yun nga, sodium, potassium, calcium, cesium, lithium. Kasi yun pa yung iba, no? Ganyan siya. And then, yung anion name, dudugtong mo lang sa kanya, no? And for monoatomic nonmetals, the ending becomes IDE, no? Kapag polyatomic, ATE pa din, no? As is pa din. So, ito yung mga examples natin, no? Ayan, sodium chloride. So, name ng cations, same pa din naman. Then, yung monoatomic anions niya. Ito, monoatomic, chloride, bromide, fluoride, tsaka chloride ulit. Dito naman is sodium. So, pansinin nyo to, no? Sodium, dalawa siya. Dalawa yung atoms ng sodium, pero sodium pa din siya. Hindi siya disodium, no? Or hindi siya bisodium, ganun. Tapos, sodium pa din. Yung normal name pa rin ng element. Ito, calcium, Ch.3 siya, pero calcium pa din. Ito, magnesium, 3. Magnesium pa din. Aluminum, yan. Al4. Pero aluminum pa din. And then for the anions nila, no, the partner, ano pa din? IDE pa din. Oxide, sulfide, nitride, phosphide, carbide, no? So, carbon din yung special, no? Carbide siya. Hindi siya carbonide, no? Or hindi siya carbode. Carbide yung tawag sa pag-carbon yung ating anion. Okay? Nag-a-act as an ion. Okay? So, ito naman yung names of some polyatomic ionic compounds. So, we have here, yan, potassium acetate. So, we have here potassium acetate. So, pansinin nyo, yun nga, hindi natin babaguhin yung kanyang polyatomic anion name. We have here ammonia, tas chlorine, ammonium chloride. Okay. And we have here, ito, sodium bicarbonate. So, ito medyo specialized. We have here HaCO3 minus, no? Yun yung bicarbonate ion, no? Bicarbonate ion. So, we have here, ito, calcium sulfate. Yan. We have here aluminum carbonate. Okay. And then we have here magnesium phosphate, no? So, same pa din. Okay. So, some metals can form more than one possible cation, no? So, this is common among sa mga transition metals natin and also sa iba pang main group elements natin or main group metals natin. So, when that happens, the charge of the metal must be shown using a Roman numeral after the metal name. For example, Fe2Cl2. FeCl2. Ano kaya ito? This is iron 2 chloride, no? Because iron is 2 plus here. So, yung exchanging ng mga charges, i-discuss din natin siya sa next lesson. Pero for this one, iyan naman natin yung naming, no? Alamin lang natin yung naming niya. So, this is iron 2 chloride because iron is 2 plus, no? So, this is iron 2 chloride. Paano pag ganito? FeCl3. So, that is iron 3 chloride. Okay? So, saan kaya nanggaling yung 2 at saka 3, no? Yung mga charges kasi niya, lalo na, yun nga, iron is a part of the transition metals group. Pwede sila mag-exist as iron 2 or iron 3 plus, no? Yung charges nila. So, yan yun. So, yung Roman numeral, it tells us the charge of the metal ion, not the number of metal atoms, okay? Isang iron pa din yan, pero yung charge niya ay 2. In this case, dito naman ang charge niya ay 3 plus. Okay? So, ayan siya. So, this table shows, no, why Roman numerals are necessary pagdating dito sa mga transition metals natin. So, a metal such as iron, copper, tin, or lead, no, can form more than one charge, no? And the formula, let us determine the metal charge from the known charge of an ion, no? Then we place that charge as a Roman numeral after the metal name. So, ito yung kanina example na dalawa. So, we have here mercury 1 oxide. So, pag ganito, mercury 2 oxide. So, si mercury very special yan. It exists kasi as Hg2, no? Tapos, 1 yung charge. Kapag Hg na lang siya, 2 plus yung charge niya, no? Medyo weird siya. So, si tin naman, ito siya. So, we have tin 2 fluoride and tin 4 fluoride, no? Okay. So, ganyan lang mag-name. And then, we have yung hydrates naman na tinatawag. Ito, madali lang tong hydrates. So, a hydrate is a compound, often ionic, that has water molecules trapped or bound with it within its crystal structure, no? May water doon na natrap sa kanya. So, when the water is removed by heating, the remaining compound is called the anhydrous compound. Okay? Anhydrous na siya pag wala na yung water. Okay? So, to name a hydrate, we first name the ionic compound normally, no? Then, we add a prefix and the word hydrate. So, for example, we have here copper 2 sulfate pentahydrate, no? So, mapapansin nyo, ito siya. So, we have here, ito yung metal natin. So, we have copper here. We have yung anionic natin na partner, sulfate. And we have here yung hydrate, no? Pero you have to check yung number niya, no? O yung coefficient sa kanya. So, copper sulfate dot, usually may dot sa gitna, no? Mapapansin nyo, may dot dito. Ganyan siya isulat. Dot 5 tapos H2O. So, that corresponds to pentahydrate. So, yung mga prefix, not familiar kayo dun. So, penta means 5 yan. So, may prefix siya na dinadagdag bago yung panggitin yung hydrate na sinasabi. So, we have dihydrate, trihydrate, pentahydrate, decahydrate. Okay? Mga ganun. So, ito yung mga, di ba? Hindi sa isa ko pa. Andito na pala. So, kapag 1 ang coefficient dun sa ating water molecule, sometimes hindi na sinusulat yung 1, hindi na nilalagay ng 1, like this, no? Calcium chloride monohydrate. Hindi na nilalagay yung 1, value ng 1. So, for that, monohydrate siya, no? Pag dalawa, di. Pag tatlo, tri. Pag 4, tetra. Pag 5, penta. And so on. Okay? Refer na lang kayo dyan sa table, no? Dito sa this prefixes. Okay, so itong figure na to, it connects polyatomic ion naming to a real case, no? So, chromium compound can exist in different oxidation states, no? Kasi part din siya ng ating transition metals. So, it can form oxy and ion forms, no? Different forms such as chromate and dichromate na tinatawag. So, asan yun? Ito yun. Chromate. Tapos dichromate. Iba natin yung color ni dichromate. So, to daw si left, si chromate. Ito. Tapos ito si dichromate. So, yun yung itsura nila, no? So, naming is not just a exercise for this one, no? Pero meron din silang significance, no? Lalo na sa environment. Itong chromate tsaka dichromate, no? Very, sila sa environment. Harmful sa environment. So, dapat accurate yung naming natin ng mga compounds na nade-determine sa mga examples or sa mga samples, sa environmental samples natin para makita natin yung chemistry nila, toxicity, no? Kung okay ba yung levels nila sa environment or hindi. So, this is just one example. So, we move on to molecular compounds, namely, itong binary molecular covalent compounds. So, molecular compounds are named differently, no, from ionic compounds. Kanina, ionic compounds yung diniscuss natin. So, ngayon naman, punta tayo sa molecular compounds, no? So, because covalent bonding can produce many different ratios between the same two elements, we must use prefixes, no, to specify the number of atoms. So, the more metallic element or the element farther left and lower in the periodic table. Farther left and lower in the periodic table. Yun yung unang pinapangalanan. Okay? The second element is named with the IDE suffix, katulad nung kanina. Then, Greek prefixes tells us how many atoms of each elements are present. No? So, ito yung basic rules. So, paano natin siya ma-apply? So, there are two important prefix rules, no, sa molecular compounds. First, if there is only one atom of the first element, we usually do not use mono, no? Hindi na siya nilalagay. For example, carbon monoxide. Diba ganyan siya? Carbon monoxide. Hindi na natin siya nilalagay ng monocarbon monoxide, no? So, second na rule, when two vowels appear next to each other, yan, same example natin, no? Sige, lagyan natin dito. Carbon monoxide. So, yung red, yung mali, no? Carbon monoxide. This is wrong, no? So, basta ito yung correct. Yung sa rule number 1, no? Hindi na natin to nilalagay, no? Okay. So, sa rule number 2 naman, sabi dito, when two vowels are adjacent or appear next to each other, the final A or O of the prefix is often dropped na, no? Hindi na nilalagay. So, ito ulit example natin, no? So, meron tayong carbon. So, lagyan natin dito carbon. Hindi, red pala. Para consistent. Carbon. So, in this case, no, meron tayong anions na oxide, no? Kapag daw may two vowels, since mono siya, mono-oxide, dapat, no? Kapag sinunod lang natin directly, and we do not follow itong rule na to. So, this one is wrong. Ida-drop na daw yung pangalawang O or A, no? So, wala na to. Okay? So, ito mali din itong example na to. Okay? So, yun. Hindi siya monocarbon monoxide. Okay? Carbon monoxide siya. So, ganun lang siya. So, ito yung mga example natin ng molecular compounds. So, this table gives us example, no, of binary molecular compounds. So, notice nyo, no, how prefixes appear in the name such as carbon monoxide, yung kanina, sulfur dioxide, dinitrogen tetroxide, no? Hindi siya tetraoxide, tetroxide, sulfur hexafluoride, okay, kanina, no, carbon dioxide, nitrogen dioxide, dinitrogen tetroxide, pentoxide, hindi pentaoxide, and ano pa ba yung kanina? Hexafluoride, sulfur hexafluoride. And ito, phosphorus decaoxide. So, decaoxide. Usually kasi, maano nyo rin siya, no? Kung maganda siya pakinggan or hindi. Isa sa mga techniques. Iodine heptafluoride. So, yan. Mga example. So, yun. Important yung prefixes dito sa ating molecular compounds, no? Binary molecular compounds. Okay? So, that's it for molecular compounds, no? We move on to acids, no? So, acids have their own naming system din, no? Iba sila. So, many acids contain hydrogen and release hydrogen ions when nadidissolve sa water. So, because the aqueous form has special chemical behavior, it also receives a special acid name. Okay? So, yung rule depends siya on whether the acid is binary acid containing hydrogen and one nonmetal, or an oxyacid containing hydrogen, oxygen, and another element. Okay? So, binary acid and oxyacid yung kailangan nating alamin dito. So, for binary acids, we have to change the word hydrogen to prefix hydro. Okay? Hydro. Yan. Hindi na siya buong hydrogen. Okay? Change the non-metal ending to ik. Okay? Non-metal element, non-metal ending, hydrogen, hydro, non-metal element name to ik. Babaguhin natin yung dulo ng ik or IC. For example, then add the word acid sa dulo. Okay, for example, ito, pinaka-famous. So, this will be hydrogen and chlorine, di ba? Pag diretso lang. So, that is wrong. So, paano natin siya gagawin? Ano yung tamang way? So, this will be hydro. Then, ano yung name niya? Chlorine. Babaguhin daw natin to IC. Hydrochloric. Then, we use the word acid sa dulo. So, that is hydrochloric acid, no? So, same sa iba, no? For example, ito, HI. That is hydrogen at saka iodine. So, what will be the name kaya? It will be iodine will be iodic, hydroiodic, and then add the word acid. Okay? So, ganun din sa bromine, no? Hydrobromic acid. Okay? So, notice that this naming pattern is used for the aqueous acid form. Okay? Note natin na this is for aqueous acid form. Okay? This is not necessarily for pure gas, no? So, pure gas, iba naman kasi yun. Okay. So, yan. Meron tayo dito mga example. So, in this table, compare nyo yung ordinary hydrogen compound name with the acid name. For example, HCl as an aqueous acid is hydrochloric acid, diba? Yung kanina natin example. HBr is hydrobromic. Ay, mali pala ako ng turo. Ito pala, hydrochloric acid. So, kapag sila ay pure gas, no? Ganyan lang sila, hydrogen chloride, hydrogen bromide. So, para silang yung sa ionic compounds, no? Pag gas. So, kapag ito sila, kapag acid sila, ito sila, hydrobromic, hydroiodic, hydrosulfuric, and we have hydrofluoric acid. Okay? So, we now move on to the last parts, no? Yung oxyacids naman, last. Ito medyo nakakalito. So, oxyacids are acids that contain, ano daw? You have hydrogen, oxygen, and at least one other element, no? Are bounded together in such a way as to impart acid properties to the compound. Okay? So, typical oxy acid consists of hydrogen combined with polyatomic oxygen-containing ion. Okay? So, usually related nga siya sa polyatomic oxy ions na tinatawag, no? This is, ito ay tinatawag na polyatomic oxy anions. Okay? So, ito yung rule, no? Omit the word hydrogen. Start from the anion root. Okay? Anion root. And change 8 with, ayan, meron kayong tatlong choice. I-change nyo ng ik, ite, or us. Ayan yung nagpapalito dito. And you add the word acid sa dulo. Okay? Okay. So, for example, nitrate becomes nitric acid, nitrite becomes nitrous acid, sulfate becomes sulfuric acid, and sulfite becomes sulfurous acid, no? So, tingnan natin yung next table. Nandito na yung mga yun. Okay. So, ito yun, acetate, no? Acetate ion, an ion name niya, acetate. So, it will become acetic acid, no? Ito, makikita nyo dito sa nitrogen, no? We have nitrate, tsaka nitrite, no? May difference sila sa charge, no? So, we have here nitric acid, tsaka nitrous acid, okay? And then, ito, sa chlorine, we have perchlorate an ion. So, it will become perchloric acid, no? So, itong susunod na example, carbonate an ion. We have carbonic acid. Ito, we have here sulfate, tsaka sulfite. It will become sulfuric acid, tsaka sulfurous acid. And then we have phosphate. Actually, meron din phosphite. It will become phosphoric acid, tsaka phosphorus acid, no? Kapag yung phosphite. Ayun. So, that's the summary of the table. And I think that's the conclusion of the week 1 lecture natin, no? Hopefully, you have gained the basic knowledge, no? So, ito lang yung parang disclaimer and acknowledgement ng reference natin. You can download the book naman, no? And check yung mga malinaw na images dito na nag-blur. Okay? Thank you so much for listening and hopefully na-cover natin yung week 1 natin. Okay, bye-bye. S8 yan.